This is a video of topic 14-5, solving quadratic equations by factoring. You should complete the bell work at the top of the topic 14-5. Our essential question is, how do I solve quadratic equations by factoring? Before we start with that, let's go and review some problems in our bell work. Which best describes the effect of the graph f of x equals 4x minus 3 if the y-intercept is changed to 8? So remember that f of x is just a fancy way of saying y equals its function notation, but our original graph is y equals 4x minus 3. It wants the new graph to have a new y-intercept of 8. So that means everything else stays the same. We have 4x, but now our new y-intercept is 8. We know this because our original equation is in slope-intercept form, where m represents the slope and b is your y-intercept. So now let's look at the answers. The slope decreases. We know that's not true because in both cases the slope is the same, it's equal to 4. G says the new line passes through the origin. I don't know about that yet. I'll leave that one alone. H says the x-intercept increases. I don't know that one yet because I haven't graphed it. And then J says the y-intercept increases. Well, I can look at that. My original y-intercept was -3. My new y-intercept is 8. And it definitely does increase. So I think J is the correct answer, but I'm going to be sure by actually looking at the lines and graphing them. To do this, I'm going to use my calculator. So with my calculator, I can graph both of these lines. If I go into y equals, I'll type in the original, y equals 4x minus 3, and then I will type in the new line, 4x plus 8. Now I'll look at the graph by hitting graph. Here's my original, and now there's the graph of the new line. So now I can see, if this is my original line, I can see, and this is my new line, G says the new line passes through the origin. That new line does not pass through the origin, so G is not it. And then it also says for H, the x-intercept increases. Here's my original x-intercept, it's positive. My new x-intercept is negative. So it definitely is not increasing, it is decreasing. So J is my correct answer. I'll now put up the answers to assignment 14-4. You will need to pause the video if you want to check your answers. So our essential question was, how can I solve quadratic equations by factoring? Well, first let's look at factoring is just having two terms being multiplied together. And so if I look at a product, again, if it's multiplication, it's a product. So if a product is equal 0, what must be true? So 8 times what number is going to give us 0? The only way that equals 0 is to have 8 times 0. The same thing, if I have what number times 3 comes out to be 0, well, that first number must be 0. So remember, our variable represents any number whatsoever. So if I have any number, what does it need to be multiplied in order to give us 0? That number needs to be 0. So if our product is equal to 0, then what must be true? The thing that must be true is that one of the numbers or both of those numbers must be 0. Because I could also have 0 times 0 will give me 0. So I'm going to write that out. If the product is 0, I'm answering my question. If the product is 0, one or both of the numbers being multiplied is 0. So that's what I just showed. In our first example, the second number was 0. In the second example, the first number is 0. And our last number, again, a variable, any number is represented by the variable, is equal to 0. And then I wrote in, I could have both of those numbers is 0, and 0 times 0 gives us 0. We're going to use this information in order to solve quadratic equations. Recall that a quadratic equation in standard form is this ax squared plus by plus c is equal to 0. So our main thing is that we want to make sure our equations are in standard form, that it is set equal to 0. Once we have it in standard form, then we're going to factor completely. This is what you did in yesterday's notes and assignment, was you took your trinomial in standard form and you factored it completely. Next, now the new thing is that we're going to set each one of those factors equal to 0. Because remember, when we factor, we're having two terms multiplied by each other equal to 0. So now we're going to take, that tells us that either what's inside this first one must be equal to 0, or what's inside the second one must be equal to 0 in order for us to multiply them together to get to be 0. So we set each thing equal to 0, each one of those factors equal to 0, and solve for our variable. So now, we are going to practice these 4 steps. We have, it's already in factored form, notice that. So step 1, we can totally skip because it is already set equal. I'm sorry, let's go through our steps. Step 1, do we have our equation equal to 0? Sure enough, we do. Step 1 is taken care of. Step 2, this is my step 1. Step 2 says factor completely. Notice this is already in factored form. We have our parentheses already showing we have 2 factors for our quadratic. So this is step 1, and step 2 is already done for us. The next thing is to set each one of these factors equal to 0. So I'm looking inside the parentheses, and I'll do 3n minus 4. We'll set it equal to 0. And then we'll also do 3n plus 5 and set it equal to 0. Last step is to solve. So here's my step 3. Last step says to solve. So I want to solve for these variables. Draw my line down the equal sign. We're going to box in our variable along with the coefficient that's with it, the 3n. I need to get rid of the minus 4, so we're going to do the opposite of minus, which is add. So we're going to add 4, and what I do to one side, I will also do to the other. What's in the box drops down. I still have a 3n inside the box. Negative 4 plus 4, that equals 0. That means I chose the right number, and 0 plus 4 gives me a positive 4. To get the n by itself, we need to get rid of the number that's in the box, and this is 3 times n, so the opposite of multiplication is division. So we're going to divide by 3 both sides. The 3's will cancel each other out, and we're left with n equals, and in 4/3 we're going to keep just as 4/3 because I cannot simplify that fraction any further. So one way in which we can get these two factors multiplied together give us 0 is if n is equal to 4/3. Because if I plug that into my first parenthesis, that'll give me 0, and then 0 times n plus 5 is going to give me 0, because any number times 0 is 0, or anything times 0 is 0. So now let's check out the other one. We have 3n plus 5. Again, I want the n by itself, so I'm going to box in the 3n. We have to do the opposite of plus 5, so we're going to subtract 5 from both sides. We still have 3n that's in our box. And then positive 5 minus 5 is 0. 0 minus 5 is a negative 5. We need to get the n by itself. It's being multiplied by 3 in that box, so we're going to divide by 3. Cancel out the 3's. We get n equals. And again, I cannot simplify this fraction, so it's a negative 5/3. So we have 2 possibilities. N could be either 4/3. That'll give us 0 in the first parenthesis. Or it can be 5/3. So that means my second parenthesis will come out to be 0, and sure enough, I will get a product of 0. We have now solved our quadratic using factoring. So let's try another one. I have the 4 steps up here. So the first thing we need to do is get it set equal to 0. Recognize that this is not set equal to 0. It is equal to 28, so that means I need to get the 28 onto the other side of the line. Or I need the right-hand side to be equal to 0. So to make it equal to 0, I'm going to do the opposite of a positive 8. So I'm going to subtract, opposite of positive 28. So I'm going to subtract 28 from both sides. In subtracting 28 from both sides, we get x squared plus 3x minus 28. equal to 0, because 28 minus 28 will be equal to 0. So now we have completed our first step. We have it set equal to 0. Step number 2 says to factor completely. So in order to factor completely, we go through our steps of factoring. I'm going to use my little visual I have here. So the first thing I'm going to look to see, do I have a GCF? And in this case, there is none. There's no number in front of the x squared, so there is none. The second step is to find our sum and our product. Our sum comes from the middle term in front of the x, that's a 3. Our product is multiplying the first coefficient of the x squared and the constant, negative 28. So 1 times negative 28, we get a negative 28 as our product. Now we need to find the factors where the product is negative 28 and the sum is 3. So I need two numbers that multiply, give me negative 28, add it to give me 3. If you cannot come with those two numbers immediately, you may use your calculator. Remember, we put the product divided by x in y1, and in y2, we do the product divided by x plus x. Y2 has the addition sign, so when I look at my table, I'm going to look in Y2 for that sum. In this case, our sum is 3. What's in X and Y1 will be my two factors, or the two numbers that will multiply to give you negative 28, but add to give you 3. So if you're using your calculator, you can pause at this time and find your numbers. Our numbers come out to be 7 and negative 4. So those are our factors, 7 and negative 4. So the last thing we need to do is to rewrite this trinomial in factored form. So we get x plus 7 and an x minus 4. But now it is actually equal to 0. So now we have factored completely. All of this was my step 2. Step 3, we're going to set each factor equal to 0. So that means I take what's in the first parenthesis, x plus 7, we set it equal to 0. And what's in our second parenthesis, x minus 4, we set it equal to 0. And now we solve for x. That's our last step. I want the x by itself. So I'm going to subtract 7 from both sides. This gives me x by itself equals 2. 0 minus 7 is negative 7. Solving our second factor, it's set equal to 0. I'll box in my x. I want to get rid of the minus 4, so we're going to add 4 to both sides. And that gets negative 4 plus 4 is 0. I'm left with x all by itself, and 0 plus 4 is 4. So here's our solving, and we have our answer. X is either negative 7 or it's going to be a positive 4 in order to get this trinomial equal to 0. I should say this quadratic, because we are dealing with quadratics today. Our next example, again, same 4 steps as before. First thing we want to do is make sure it's set equal to 0. So notice one thing right off the bat. Our quadratic equation, we always want, and I just recognized an error here. This should be b times x, not b times y. It should be in standard form where we have our x squared followed by our x followed by our constant. And so in number 3, this is not in standard form because I have an x squared, but then I have my 15, and then I have the x term is on the end. So I'm just going to rewrite, and I'm going to take the sign that's with the coefficient of the x, and we're just going to rewrite it as x squared. Move this so it's negative 12x, and then minus 15. This is now in standard form where I have my x squared, and then the minus 15. So the first thing we need to do is factor it. We got it set equal to 0. Now factor completely. First rule of factoring is, does it have a GCF? And in this case, we see that there is a number in front of the x squared. That number is a 3. So let's see. Can 3 go into 12? Yes. Can 3 go into 15? Yes. So we do have a GCF of 3. When I have that GCF of 3, then I'm going to factor it out. So I have a 3 up front. And then we have x squared minus 12 divided by 3 is a 4. So 4x, and then minus 15 divided by 3 is 5, equal to 0. We have factored completely. Oh, no, we haven't factored completely. I'm sorry. So let's go on to finding our, we did the GCF. The second thing is find our sum and product. So the sum, this is why we had to put it in order because our sum is what's in front of the x, which is -4. And our product, we multiply the coefficient of the first and last, and that'll be a -5. Then third step of factoring, we find those factors. What two numbers multiply to give you -5 but add to give you -4? Those two numbers are going to be -5 and 1. If I multiply them, I get -5. I add them, I get -4. And so last then, I write it in factored form. So I have 3 out front, and then x minus 5 and x plus 1. They all have to multiply together to give me 0. So now we have factored completely. So now we need to set each factor equal to 0. Notice in this case I do have 3 factors. I got the GCF, and then I have what's inside the parenthesis and what's inside the parenthesis. So I just have my students take everything, any factor, and we set it equal to 0. So this is step 3 up here. So we're going to take the GCF, set it equal to 0. We have the x minus 5, we set it equal to 0. And we have the x plus 1 and set it equal to 0. Well, I did the first, the GCF, because I have students who get confused sometimes. But can 3 equal to 0? Nope, 3 is not equal to 0, so that means I can totally ignore this because these are just two numbers. It's nothing for me to solve. So now we're going to solve for x with the x minus 5. I want the x by itself. I need to do the opposite of minus 5, so that's plus 5. We'll add 5 to both sides. This gives us x is equal to 5. Then we have x plus 1. That's my second factor. Get the x by itself. We're going to do the opposite of plus 1. We'll subtract 1. And we get x is equal to a -1. Because 0 minus 1 is -1. So this tells us we have two solutions, 5 or -1. If x is equal to any one of these two numbers, when I plug it back into this quadratic, I will get 0. Example number 4. Okay, first step, we need to get it set equal to 0. Again, let me go ahead and correct that. Set it equal to 0. That means we need to move the 6x. So I need 0 on the right-hand side, so I'm going to do the opposite of the positive 6x, which is this minus 6x. And then I can rewrite this because I cannot combine x squared with the x. So it's just 3x squared minus 6x is equal to 0. So we took care of step 1. Step 2 is factor completely. To factor completely, first thing we look for, what's the GCF? I'm going to look. I see, hey, I do have a 3. And 3 does go into 6. So I do have 3 as a GCF. The other thing I notice is I only have 2 terms here. And so since I have 2 terms, I'm going to look and see what about the x's. I have an x squared in the first one, but an x in the second one. So they both have at least one x. So my GCF is going to be 3x. When I take the 3x and factor it out, divide everything by the 3x, we get 3 divided by 3. That leaves nothing, but x squared divided by x, I have 2 x's on top, 1 x on the bottom. That's going to leave 1 x on top. Minus 6 divided by 3, that's 2. And then the x's will cancel each other out. So in factored form, when I factor out the GCF, I get 3x times x minus 2. And again, this is still equal to 0. So I cannot factor anymore because look inside the parenthesis, there is no squared term. It is raised to the power of 1. That means I cannot factor anymore. We're going to set each factor equal to 0. That's step 3. So we'll take 3x, set it equal to 0, and then x minus 2, set it equal to 0. And then my last step is to solve. So let's solve. I have 3 times x. I'm going to put that in my box. To get rid of that 3, I do the opposite multiplication. That means divide. So 3 divided by 3, the 3's are gone. I'm left with an x, and 0 divided by 3 equals 0. My other factor, x minus 2, so we're going to add 2 to both sides. X is still in the box, it's by itself. I can drop it down, and a negative 2 plus 2 is 0, and 0 plus 2 is 2. So we have done all 4 steps, and my answer is X can be 0 or X can be 2. Again, if I plug this back in, if it's 0, notice that would be 3 times 0 squared equals 6 times 0. We do get 0 equals 0. That works out. If X is equal to 2, we'll get 3 times 2 squared equals 6 times 2. Well, this is 3 times 4, which is 12, equals 12. That's a true statement. Our last problem, we have the area of a rectangle. An area of a rectangular room is given by the equation 2w squared minus 14w equals 36, where w is the width of the room. We want to find the width. So you should notice that this is a quadratic because we do have a x, or we have a squared variable there that tells us it's a quadratic. The only thing is our variable now is a w rather than an x. We're still going to use those same process in order to figure out what w is. I need this quadratic set equal to 0. So we're going to move the 36, subtract 36 from both sides. We now have 0. And then on the left-hand side, I cannot combine anything, so we have 2w squared minus 14w minus 36. That comes out equal to 0. We've taken care of our first step. Second step is to factor completely. So to factor, I need to start off with, do we have a GCF? I see there is a number in front of the w squared. It's a 2. So let's check and see, can everything be divided by 2? 14 can be divided by 2, 36 can be divided by 2. So 2 is a GCF. And when I divide out the 2, I end up with w squared minus 7w minus 18. This is now equal to 0. So second step, we need to factor completely. When we factor completely, we have the 4 steps to that. We've already taken care of the GCF. Oh my gosh, I did my things wrong. This is actually step 2, factoring out the GCF. It's the first step, so sorry. Second step then is to find our product and sum, or sum and product. The sum is the number in front of your variable that's raised to the 1 power, or what's in the middle. That's the negative 7. Your product, we multiply the first and the last coefficients, and that'll give us a negative 18. Third step of factoring, we need to find the factors. What 2 numbers multiply give you negative 18, but add to give you a negative 7. That's going to be a negative 9 and a positive 2. Last, we rewrite it. So we have a GCF out front. Inside, we are going to have w minus 9 and then w plus 2. Again, this is equal to 0. So we have now factored completely. Called this step 2 of our solving. Step 3 then says to set each of those factors equal to 0. So I'll do 2 equal to 0, w minus 9 equal to 0, and then w plus 2 equal to 0. Those are all our factors. Notice the first one is numbers. There's nothing to solve. 2 does not equal to 0, so we cannot solve that. That's not one we're going to use. The second one, we have w minus 9. Let's solve for w. We're going to add 9 to both sides. To get the w by itself, we get w is equal to 9. Let's look at the last factor, get w by itself. We have a plus 2, so we're going to subtract 2. That'll give us w by itself, and 0 minus 2 is negative 2. So now that we've solved, we now need to answer the question. The question was to find the width of the room. So this gives me 2 possible widths. Our width is either 9 or it's negative 2. But let's think about that. Can you have a width of a room that is negative 2? And you should come up saying, no, absolutely not. So we are going to get rid of this negative 2 because I cannot have a negative width, and my answer is the width is equal to 9. So when we're solving real-world problems, real-world situations, like finding the length or the width of something, remember you cannot have a negative width, and so that will toss one of your answers out if it comes out to be negative. Okay, this concludes your topic 14-5.